Okay, so here's a different way to teach the factoring that we did in lesson 5.7. So again, we're looking at two binomials, and this is what we've been doing, multiplying them. So what's the product? We do the x times the x. We do the x times the -4, the -6 times x, and the -6 times the -4. So what do we notice about the product patterns? Well, all of these, or most of the ones we've been looking at so far, are the x squared in front. There's no coefficient in front of either of these x's. That's why we get x squared. We can also see that this is always, that this is positive because these are both negative, and because they're both negative, the 6 and the 4 are added together. So we are usually adding the OI terms of the FOIL method. The first, the outside, inside, and the last. So if you were doing a bunch more, you would see these same sorts of patterns. Now we're going to be working backwards. We're going to see the trinomial, and we're going to go backwards to the factoring, to its factors. We've already looked at two patterns, the difference of two squares and the perfect square. So now we're just going to be looking at two different binomials multiplied together. When we have these two binomials and we FOIL, we get the x squared, the outside is the 5x, the inside is the 3x, and then the back end is the 15. So the first term in the trinomial comes from multiplying the first terms in each binomial. So the x squared comes from multiplying the x and the x. The last term, the 15, comes from multiplying the 3 and the 5. The middle term is the addition one. So that one's where we just have to think a little bit more, because we are going to get a 3x and a 5x, and we add them together to be that 8. For these cases with no coefficient in front of the x's, or when we start with the trinomial, it'll be no coefficient in front of the x squared. Then all we have to do is find factors of the last term that add up to the middle term. And that's because when we were multiplying, we had 5 times x because there was no coefficient, and we have 3 times x because there was no coefficient. So that's why it's just 3 plus 5, because we had no coefficient that we were multiplying by. I'm making that distinction because in a couple more lessons, we're going to have a number in front of the x squared, and then it's going to get more complicated. But for right now, when x squared has nothing in front of it, no number, just a 1, then all we're multiplying by is 1 and these numbers. So for factoring x squared plus 14x plus 40, we're going to list pairs of factors for 40. We always start with 40 and 1, so the number in itself. And then I just go up from 1. If it's divisible by 2, then I'd put 2 times 20. I keep going up the ladder. Is it divisible by 3? No. How about 4? 4 times 10. Keep going. 5. Yep. 5 times 8. What about 6? Nope. 7? Nope. And once you get to the other side of it, so we were going up from 5, 6, 7. Once I get to 8, I can stop because I'm just going to go back down. And then I'm going to have the same list. It's just going to be in the other order. So which of those pairs add up to 14? Well, it's this one right here. So now we're going to set up our two binomials. That no coefficient with the x squared means we can put an x in the first part of each set of parentheses. So we have an x, and then we're looking at our signs here to know if it's plus or minus. As long as it's a plus here, then we know that the signs are the same. And then the signs that are the same are whatever this one in the front is. And that makes sense because remember, we're multiplying the signs to get this one, and we're adding the signs to get this sign. So if it's positive that we added together, then it's two positives down here that we need to add. And we're going to write the 4 and the 10 because those were the two numbers that multiplied to be 40 and added up to be 14. right, so let's take a look at this one. There's no coefficient in front of the x squared. So we start our binomials both with the x. So I can just put my parentheses sets down and put the x in there. And then I'm going to look at numbers that multiply to be 6, but add up to be 5. I also have plus signs both here. So plus sign here means they multiply together to give me a positive, and a plus sign here means they add to give me a positive. So I must be working with addition. Okay, so 6 and 1 is going to add up to 7. That's too high. But 2 and 3 adds up to 5. All right, example 3, x, this should be a squared. Let's see. Okay, x squared minus 11x plus 18. With no coefficient in front of the x squared, we know that we can start our binomials, our factors, both with x's. But we see we have addition here, so they multiply together to give us a positive number, but they're adding up to give us a negative number. That means that our factors must both be negative. So we're going to subtract in our binomials. So they multiply to give us a positive 18, but they add up to give us a negative 11. So factors of 18, we have 1 and 18. 18 is divisible by 2, so we have 2 and 9. 18 is divisible by 3, so we have 3 times 6. And then it's not by 4, it's not by 5, and then once we get to 6, we're on our way back down. So these are our 3 sets of factors. Which of them add up to 11? Well, none of them, because I wrote them as positive numbers, but if I make them all negative numbers, they'll multiply to still give me a positive, but they'll add up to give me negatives. So then this is the set that adds up to give me negative 11. So I put the negative sign in here, the 2, a negative, and a 9. All right, let's go through these last few examples. X squared plus 9x plus 8. No coefficient, so I can put my parentheses and I can start with x's because I don't have to worry about a number in front of the x. So these will be x squared. Now look at my signs. I have positive, so I know they're both the same sign. And this positive means they are positive numbers. Factors of 8 that add up to 9. Now, whenever I look at 8, factors of 8, and then they add up to something even bigger, I pretty much know that it's 8 and 1, because that's the only way I'm going to get bigger than 8. So 8 plus 1. All right, this next one's a little bit tricky. I have an a squared here, so I know that I'm doing something, 2 factors. This is a instead of x, but there's no number in front, so it's just an a. I look at my signs, they're the same sign because they'll multiply together to give me positive, and they add up to give me positive, so I know that I'm adding. But then I look and I have this b squared here. What does that mean? It means that I'm going to have a b over here with whatever number I choose. So I still haven't done the numbers yet, but I know that it's going to be a b. And that's where the ab comes from, because when I multiply, remember that middle term comes from adding my outside and inside, multiplying. So my outside and my inside, you see now I have an a and a b and an a and a b. And then I have some number in front of the b that multiplies to give me 24 and adds to give me 10. And 24 is not divisible by 5. If I get up to 6, I'm back here and I'm going to go back up. So I'm done with these 4 sets. And which one adds up to 10? That one right here. So I'm going to put a 4 in front of this b and a 6 in front of this b. Does it matter which one I put a 4 and a 6 in front of? It doesn't. The signs are the same, and we know that in multiplication, these factors, so the things in parentheses, can be done in any order. So I could have switched the parentheses sets. All right, what about this one? Factoring 75 plus 20y plus y squared. Well, now I have 75 in front, so what goes in my front? Oh, let's just switch it around. Let's think of it as y squared plus 20y plus 75. Now I have a y squared in front. There's no coefficient, so I know that y is my first part of my factor. They multiply together, whatever's over here, multiplies together, give me a positive 75, so the same signs, adds up to give me a positive 20, so the signs must be positive. Factors of 75. Well, that adds up to give me 76. 2, oh, it's not divisible by 2. How about 3? 3 times 25, is it not 4? It is divisible by 5. 5 times 15. 6, no. 7, no. 8, no. 9, no. 10, no. 11, 12, 13, 14. I'm back to 15. So I think there's only 3 factors, 3 sets of factors. And which one adds up to 20? This one right here. So I can put the 5 and the 15 in.